Start, Atharva.
The title of our project is an affordable solution for automatic number plate recognition system for Indian license plates. Our project is guided by Mrs. Jaya Devan, and our team consists of Atharva Jadhav, myself, Omkar Dongre, Deepak Patil, and Tanmay Shinde. This is the outline of our today's presentation. Moving on, let's first understand the problem. We often visit our acquaintances where we are asked for our basic details by security guard in order to maintain the data of visitors. Here, the data is generally maintained manually where security guard fills the data in the register box. This data leads to error as can be seen in the image, and hence this error-ridden data is quite useless as we can see. So this puts the residents of the society at danger. So approaching the solution. So what we can do is build an automated system that can read the number from the number plates through video processing and store this number in a central consistent database where, along with the visitors information. This will certainly reduce errors and hence ensure the security of residents. So our aim of project is to develop an affordable, consistent, and easy to use system that can handle data of visitors, which will ensure security of residents. Our objectives are to build a robust and accurate video and image processing model that will extract number from vehicle. This model will be deployed on a fluid web-based app, which will be easy and understandable for watchmen, hence ensuring a fluid user interface and a better user experience, and also to maintain a central database that will handle data efficiently and which will be error free. Moving on, this is the external view of our system. As we can see, the primary user is a security guard. He will handle and manage residents and visitors by doing following things. To control the security guards, an admin will be appointed so that he can manage the logins and the other things of security guards. This is the block diagram of our system. So basically, the input to our system is a video footage. From the video footage, we will detect movement, and once that movement is detected, the frame will be scanned for vehicles. If a vehicle is found, the license plate from the vehicle will be extracted, and on the extracted license plate, character recognition will be performed. This extracted number will be compared with residence table, and if no match is found, that means it's a visitor's vehicle. If it is confirmed it's a visitor's vehicle, we will simply fill a form for visitors details, and this will be stored in the database. So in the database, we will have a resident table which will have the information about residents too. This is the statewide architecture, how our system will exist at a certain point in the system. Initially, a login is a must for security guard, where after login, where he will be guided towards the dashboard, and from dashboard he can perform multiple things which will be explained in the demo. So this is our work breakdown structure. So initially we recognized and defined the problem. A clear definition is necessary for development of the project. Then we formulated our aim and objectives so that we can have a clear focus on what we are going to develop. As necessary, we performed literature survey on the existing works and tried to find out the best and optimal method for our system. For the planning part, we divided the system into three major modules. The first is image processing module, then web development module, and code documentation. Image processing module is divided into four submodules as it can be seen in the figure. The first is A1, detection from moving objects from videos. The A2 is detecting objects as vehicle and non-vehicle. The third submodule is plate localization, and the last submodule is character recognition. Similarly, the web development module has been divided into two submodules: front end, that is web development part, and the back end, which is the database or back end development of part. For resource allocation and development of project, I had to carry out the A4 and B1 modules of the project. Deepak was assigned A1 and B2 modules of the project. Omkar was assigned A3 and C, that is code documentation, and Tanmay was assigned A2 and C, that is code documentation part of the project. Moving on to the technical part, let's analyze the image processing module that we have implemented. This is the block diagram of a moving object from the videos. This part has been developed by Deepak, and he will explain further uh, all the submodules of this part. Deepak, kindly proceed ahead.
Thank you, Atharva. Now, this is the first most step to moving detection object. Now, it is one of the crucial methods in our video processing. So basically, we will take an input video and we will scan that video frame by frame, and I have applied a GMM module initially, but then I applied a background subtraction model, which was yielding a greater efficiency as compared to the GMM module. Now, now after that, when the movement is detecting, I will capture the most appropriate frame, and I will send and I will collect more of these frames uh, in the video sequence, and I will forward those frames to the next module. Otherwise, next slide, please.
Yeah, Tanmay has developed this module of detecting object as vehicle or non-vehicle. So he will tell us more about this part. Tanmay, kindly go ahead.
So detecting object as vehicle, non-vehicle. In this, after receiving the most appropriate frame, it is first read. Then pre-processing operations are done. In this pre-processing operation, first we resize the image for 416 by 416 and convert it to grayscale. The reason we convert it to grayscale is to reduce the number of parameters. Lesser the number of parameter, lesser will be the computation. Now, the necessary condition for forward propagation is converting the image into blob. So blob image is created and it is passed for forward propagation. Then YOLO algorithm is applied. So YOLO algorithm steps are like we have to divide the image into n by n grid cells. Then multi-label classification is performed per cell. So for per cell, k bounding boxes are predicted. Each bounding boxes consists of a matrix. That is, a matrix is associated for per bounding box. That matrix contains the bounding coordinates, that is the center coordinates, width and height of the bounding box, and the classes. Here the classes are vehicle or non-vehicle. Now after generating the class bounding box and the matrix for per bounding box, then we have to find intersection over union and non-maximum separation. As per object, we are finding k bounding boxes. So we have to find the perfect bounding box. For that reason, we have to use intersection over union. If the value is above zero point 0.5, then we'll say, select those bounding boxes. And lastly, we apply non-maximum separation. In this, the bounding box having the maximum confidence score is used. Now, the image is classified as vehicle and non-vehicle. Now, the bounding box coordinates are used to crop the image and it is passed for localization.
Yes, the next module is number plate localization. It is a process of extracting number plate region from the image. The work is done on the RGB image obtained from the bounding box generated by YOLO algorithm. Instead of working on complete image, it is better to remove the unwanted region in the image, thus increasing the accuracy and reducing the execution time. The Gaussian blur is applied on the RGB image to reduce the noise. Then Sobel edge detection is computationally less expensive and its accuracy is also good, so it is used for edge detection. Then thresholding is done by auto thresholding method. Then morphological dilation operation is performed on binary image to enlarge the boundaries of the foreground pixels. Then contours are generated and analysis is done based on the shapes, area and angle, and thus based the major criteria is the aspect ratio. So on the basis of that, the exact number plate is extracted. and thus this is sent to the next model, that is character recognition model. The answer will explain the character recognition model.
The final part of image processing module is character recognition. The input to this module is the extracted number plate in the last part. It is necessary to perform pre-processing on the image for skew correction. For skew correction, pre-processing steps like bilateral filtering, detail enhancing, followed by grayscaling and canny edge detections are necessary so that the edges are preserved of the image, which will help us to detect the hog lines that are drawn on the image. So all the hog lines that are in between plus minus 15 degree are considered for skew correction. The average of all the angles for all the hog lines is calculated and image is rotated in opposite sense with respect to the average angle that has been found. Once the image is skew corrected, it is further passed for character segmentation. For character segmentations, contours are used. The external hierarchy contours are used so that all the characters are recognized individually. Also, there are some extra contours like the bolts, rivets that are present on the number plate, which are not the original data that we require, but are the outliers. So, in order to remove these outliers, we can consider the ratio of our contour and the plate's height. Nearly all the characters will have the similar ratio. Hence, all the other data that is there recognized as a contour can be discarded by using outlier detection with standard deviation. Further, once all the characters are segmented out, it is necessary to train a neural network that can classify these characters individually. For prior to the recognition part and training part, since this project is focused upon the Indian number plates, we can use the constraints that are put by the government. So the first two characters on the number plate are representing the states. So there are only a few characters that can be trained for the recognition purpose. Similarly, followed by these two characters are the two digits which represent generally the districts of the state, and also the last four characters are digits that represent the series of the number. The only thing that is that needs to be trained on all the 36 classes of A to Z and 0 to 9 are the prefixes that are added before the last four digits. Also, there are some constraints like since it is told that there are two digits that will follow the state code. For some states like Bihar, Delhi, it is not necessary to include a zero. For the states which have like numbers like 0, 1, 0, 2, they can simply go with 1, 2, 3, as opposed to which one we have in Maharashtra, like MH01 is compulsory. So moving on to the technical part now, a mobile neural network can be fine-tuned for this case, since MobileNet V2, as compared to other architectures like ResNet 50, Inception V3, has less size, less number of parameters, and also the accuracy trade-off is minimal, like it's in 3 to 10% only. So once this neural network is trained, we can deploy this neural network to recognize each segmented character and form a number string. This number string can be further passed on to the web development module where it can be further processed. So the requirements for the project are: operating system can be Linux or Windows. Linux is used as it is open source. Python 3.6. Internet connection is necessary initially since it is a web-based app. Also, web browser can be used as Mozilla Firefox or Chrome. Internet Explorer might fail to render front end, which uses Bootstrap. Hardware, the memory space required is 500 MB. RAM required is 4 GB. Video card is optional, and a digital camera is must to record the videos. So these are the image processing results of our module. As we can see, a vehicle is approaching towards a society. So as it stops near the boom barrier, we can the moment detect the moving object detection algorithm works and extracts out the frame that contains the moving object. Now it is necessary to classify this object as a vehicle or non-vehicle, which we can see here. A bounding box is drawn around the vehicle. This bounding box will help us to focus only on this portion since it contains the vehicle of interest, which will increase the accuracy of our number plate detection module, and hence the number plate detection module will detect the number plate. Now this number plate will be passed on to the character recognition part, and as we can see, the characters are recognized through the module. For the web development part, we have divided it into sub-modules as told earlier. The technology stack for front-end is HTML, CSS, and Bootstrap 4. And for backend and database, Python Django is used for backend development, and SQLite 3 database has been implemented to maintain the data. So these are the results of web development module. You can see a fluid and easy to use web-based app which has a login dashboard. Then these are the particular parts of all the tabs that are present on the residents, like manage residents, manage visitors. We can also see the visitor information here, then resident information. Then we can also create all the log files for the visitors that have visited the society. These are the references which we have studied earlier to implement our system successfully. Thank you. This is the GitHub link. Now I would like Deepak to show us the demo of the project, a working demo, so we can understand the implementation part of the things that we have explained earlier here.
Thank you, Atharva. Now I'll explain the project actual implementation of our project.
Start Deepak.
Hello everyone. Now let us study our demo project. The title of our project is Automatic Number Plate Recognition System as studied before. Now this page, as you see, is the login page through which the security guard would log in at his current shift time. Now he will log in. Now as the page is getting loaded, our dashboard, appropriate machine learning models are loaded that are required for our video processing. Now, as we can see, we have kept this dashboard as simple as possible so security guard won't be overwhelmed with the number of options that he have to select. Now, the first block involves managing the residents. Now here we can see and we can add, view, update and remove residents. And here we can see now the existing data resident table consists of one entry whose name is test resident 1 and the vehicle number corresponding to it is this. Okay, now let us focus on the main important part of our project. Now let us go to this access module, and here we would select input video that is given to our system. Okay, then now for our purpose, let's select the first video as test video 1. We need to check whether it is a visitor or vehicle, is visitor or a resident. Now let's check this one. Now I have selected this video. As you can see, input video selected, test video 1. Now I will process this. Now as you can see, the video is getting processed and it has extracted this number plate number output string from the vehicle that I have given input to our system. Now we will input the information. Now let the visitor name be test visitor. Visiting resident would be test resident test resident 112 for the purpose, and for contact number let be any number, 10-digit number, anything like that, and owner name would be test owner, and vehicle type is four-wheeler. Now, as we have filled this form, the security guard will now save this, and once the data is saved, it will redirect the system would be redirected to the dashboard. Now, as we can check this, we can access this manage visitor section. As you can see here, we can visit, we can see which visitor has visited our society. As you can see, the visitor name is test visitor that has been entered by the watchman, and it is visiting the test resident 1 2 section. Apart from this, this section also involves generating the log file, and we can also email that log file to the concerned person. That's a cool feature, right? Now let us take another scenario. Now we would check another video, test video 2, whether it is a visitor or it is a resident. Now I'll select test video 2. As you can see, I have selected the test video. Now I will process this video. Okay, now as we can see, it is saying welcome resident. So now earlier I showed you that the resident table consisted of existing resident, and it was named as test resident 1, and it has a vehicle number. So it is the resident resides in our society. Now all of this is done. Now this is the main feature that we have implemented. We have created a manage resident section, manage visitor section, and we have actually implemented a module which would which would handle the videos, and it will extract the output string from it. Now at the end of the shift, the watchman can sign out, and the next security guard can continue his shift by entering his appropriate credential. And thus we have implemented a system, automatic number plate recognition system, that solves our problem. Thank you. Omkar, stop.